All right, go.
Oh, sis.
You come up here and do it, Robert.
2.7 solving by graphing.
Thank you, Robert, for that lovely
Say like
introduction.
2.3 like you usually do.
All right. Before I show you about solving by graphing, I need to refresh you a little bit on a couple things. When I say this word, tell me what you think.
I think
Y.
X and Y.
You think X and Y. What about X and Y? Where it crosses an axis. I can have, I told y'all that's not me.
What are you talking about?
Crosses, no, Robert, don't be ugly. Crosses an axis. Okay, no, stop being ugly. Okay, where a graph crosses one of the axes, I can have an x-intercept, I can have a y-intercept, right?
Mm-hmm.
Okay, tell me what happens at that intercept.
It literally goes
Or
across.
let me be more specific. Okay, it literally goes across. What happens at every single x-intercept on the graph?
There's only one.
There's only, you could have more than one. Close. Y is 0, right? Every single time, think about this graph. And let me just put a parabola on here. Let's say this was -1, 0, 3, 0. Every single time that graph hits that x-axis, y is going to be 0. Every time, every time. By definition, that's what we mean by x-intercept, right? Not just that it's crossing, but that y value is 0. That's giving me, okay?
Right?
That's why we cover it up. When we're doing, good job. When we're doing the standard form of a line, that's why we do cover up. Because we're finding those. Remember we did that in chapter 1? All right. So then, extend this a little bit further. If I'm talking about the y-intercept,
X is 0.
then the x is 0. Okay? So I could find the intercepts graphically by looking at those graphs and finding where it crosses each axis. Or I could find them algebraically by subbing these values in, right? Does that make sense to everybody? So let's do something. Let me give you an equation. Let's say, let's start easy. Let's start with a line, Robert. Let's do,
This is an example.
yeah.
Plus 2.
Let's find the x and y intercepts, okay? And then we'll extend this just a little bit. Okay?
We already have the Y.
We already have the y-intercept, but let's do it algebraically. Let's just run through the steps on how we do it. So the y-intercept, I know that this is in slope-intercept form, and I could just take the b. But remember, x is always
What? 0?
0. So if I plug 0 in here,
Oh, I did not know you could do that.
this is what I'm saying. I want to go through algebraically and
I did not
justify.
know you could do
Dylan, come on.
that. I thought you could only do that in standard form.
Any form you're in of any equation, this works.
You just put in 0 for
If I'm in a quadratic, a cubic, a quartic, anything, if I put 0 in for every x, I'm going to find the y-intercept. What? You did not know that. I'm glad you had such an epiphany on that. You knew that? Good, Luke. I'm glad you knew that. But, all right, 1/2 times 0 is 0, and 0 minus 3 is. So this little line should be crossing the y-axis at -3, right? How about the x-intercept? You do this on your own real quick, and then we'll do it together. Always. Always. Do it. You got it. You got it. Let everybody get it. My goodness, y'all are just brutal to each other. I just have trouble believing that, Coughlin.
I got it.
All right, if I put 0, and this is a basic, easy one, so I'm going to go ahead and move on with it. If I put 0 in for y, and I'm going to go through and solve, right? So I'm going to add 3 to both sides. That's exactly right.
And then you multiply by 2.
Nice. And the answer is 6.
I graphed
started -3
I want you to do it algebraically first, because what I'm going to do is I'm going to show you how algebraically and graphically we get the same thing so that we can build on that and then move on to our quadratics and our absolute values and our everything else, any other kind of equation that we have. Yes, Robert?
Oh, okay, we did.
Because you don't.
Don't divide by a fraction.
Negative 1/2 equals
You
3.
flip the sign.
No, because you don't divide by a fraction. You multiply by a reciprocal.
You flip it over.
So instead of dividing by a half here, we multiply by 2 over 1. All right, here's what I want you to do. Take out your calculator and graph the line y equals 1/2 x minus 3. If you put a fraction in, you probably need parentheses. 1/2 x minus 3. Hit menu.
It goes straight across. Oh no. What's the equation? What's the equation?
Do a zoom 6 on it. Hit y equals. Look, hit y equals. Hit the button that says y.
I've got to say you just calculated with x.
All right, do we all have this line graphed? Are we all on a zoom 6 here? Give me your eyeballs if you do. I need to know that you are with me before I do more. Okay.
What is Zoom 16 do?
Zoom 6 gives us a standard window, a 10 by 10 window.
So I press zoom in 6.
All right, zoom in the 6. Now listen, when I look at this, I can kind of tell here that it's crossing at -3 and at 6 we're supposed to, right? But because we're going to get into some kind of wonky graphs, I need to make sure that I can calculate exact values, all right? Now, this is where you've got to stay with me and you've got to do everything I tell you to do. Hit the button, second trace.
I got it.
Second is the blue button. Trace. All right, different calculators do it different ways. I can definitely help with the Casios, the Inspires. I'm not as good, but I know that you go through analyze on there, okay? So at this point, everyone on their calculator should have these options somewhere on there, okay? That's if you don't have an Inspire. Okay? I'm going to choose, yeah. I'm fixing to get there. All right. Here's what we're going to do. Another word. All right. Another word for the x-intercept is 0 or root. That's about it. 0 or root, okay? So we're going to choose, if you're a TI with me, you're going to choose option 2. If you are a Casio, you're going to choose the option of root, and I'm not sure what the Inspires say.
Why wouldn't we press intersect?
Okay. So we're going to do 0.
Why wouldn't we press intersect?
Because intersect is when you have two different graphs and you're finding the point of intersection of the two graphs. Okay. All right, so choose 0. Now here's where it gets confusing, so I need you to stay with me. If you're a Casio, as soon as you chose 0, it calculated the 0 for you. Okay, or you chose root, it calculates the root. If you are a TI, either an Inspire or this TI, then you're going to have to go through these steps, and this is where it gets confusing for students for some reason. Do you see my spider that is blinking?
Yeah.
Scroll him over until he is close. It doesn't have to be exact, but until he is close to the point where it crosses the axis. Okay?
That's not the left bound now.
It's not. It's not. Now it's asking you for left bound. So what you want to do is you want to click left until you are sure that you are cleared of the axis on the left side. So I'm going to click left. I'm sure that I'm past the axis there. Okay? The left arrow.
Wait, which axis do we need to pass?
We're looking for the x-intercept, so we're past the x-axis. We hit left until we're past the x-axis enough and hit enter. Now notice, you see this little arrow that popped up top? What I am doing, okay, and if you understand what it is you're doing, it's a little bit easier to find the bounds. You're giving it a range, okay, and you're saying between here and here, find the place where it crosses the x-axis, all right? So I've given it a left bound. Now I want to give it a bound on the other side. So go back to the right and go, okay, I definitely want to clear the axis going right. Keep going, keep going. Okay, I'm going to say that's good. All right?
Enter again.
And hit enter again. Now look at my two arrows that are up top. If I drew straight lines down from the edge of those arrows, would your x-intercept be between those two lines? Yes, that's what I need. So hit enter one more time. And it should give you the x-intercept. Yeah.
So can we do the same thing with the line?
Yours automatically goes there. As soon as you hit root, it goes there.
Wait, I'm gonna try with my cat.
I want everyone to hear this when I say it, okay? Do not use trace to find your zeros or any critical points that you need to find. Okay? Here is why. If I hit trace, trace is giving me the values as I click along this line, right? And I might come to where I think it is. It is not going to be as precise as calculating the value, okay? You need to calculate that value, period. You need to go through left bound, right bound, enter. Otherwise, it is not exact. And if it's not exact, it's not going to be right. Now, I think that inspires, if you start tracing, excuse me, you will get to a point where it'll say, oh, that's the zero. And if that's the case, then fine. But everybody else, you need to make sure that you are calculating the zero and you are not tracing. Okay? Now, it didn't work?
Line work.
Well, she should still be able to do the bound of finding the roots is so that we can solve some equations. For example, let's say I had, what's going on? Let's say I had, and I needed to solve that, okay? What I have here is I have a 0 in place of the y. Do you agree?
So you're looking for the x-intercept?
So if I graph this
We'll get more than one.
and I find the x-intercepts, then what I have essentially done is I have solved it for x. And you're right, there could be more than one on here. So let's do this. Let's see if we can find the solutions to the equation without actually going through and solving algebraically. Now, the first example we did, we solved algebraically, right? We put the 0 in, we added, we multiplied, we found out the value of x. But what we can do is we can just stick it in our calculator and we can find the
second one, right?
roots. Yes. Well, it's the same thing. One of them just, yeah, the same one.
So I don't have to graph that by hand. I can put it in my calculator.
You can always say, I was just showing you that essentially, if you graph this, what you've done is you've graphed that equation, but you've let y be 0. Okay? All right, so 2x squared plus 3x, what'd I say, minus 1? A zoom 6 is a good place to start. Now,
Wait, let's go back to
It's a parabola.
it's a
I thought
parabola.
it'd be 2 lines. I don't know how. Because it's like the parabola and then like a regular line. Because it's 2x squared plus 2x.
What?
Or 3x.
No, it's a parabola. It's a parabola.
Well,
We're going to
where's
talk,
the
next
plus
chapter,
3x?
we'll really delve into parabolas.
Where
but
does the plus 3x come in? Because that's not like the line of the...
It's not, a standard form of an equation of a parabola is ax squared plus bx plus c.
Yeah. I wanna-
But we'll get to all that. But for right now, I just want you to know how to find the zeros. All right, so if I find the zeros here, I want to do second trace,
0.
0.
We're trying
Okay.
to get the x, right?
Mm-hmm. So I'm going to go left bound. All right, notice there's 2 here. Start going left and right and you'll find it. If you look at the bottom, the coordinates that are on the bottom are the coordinates of where your spider is right
Why did you
now.
write x plus 1 times x minus 1?
my Spider-Man.
What?
And your box.
That's old. I don't know why it's stalled out right there.
I didn't know where to go now.
My Spider-Man.
There's 2 there, okay? So I'm going to do each one of them, and let me show you. The first one is somewhere around right here, right? So I'm gonna calculate that. I'm gonna go left bound and hit enter.
So don't.
I'm gonna go right bound and hit enter. And enter again. You see how I wouldn't get this doing trace?
Okay, my X got. Oh yeah, I got that. Why is it? It says negative
Because it's not an exact number, and that's okay.
We round.
Yeah, ran out two
So
places.
negative. So 1.7.
Negative 1.78. You would have never solved that algebraically to get that. You don't know how to solve that yet algebraically.
Does it
Okay?
count?
It's a chapter 3 thing. We're gonna do it.
I'm already willing.
Okay?
Negative 1.8.
Negative 1.78. Okay? But it has two x-intercepts, so you go ahead and try to find the second one on your own and see what happens.
Okay. Put it right in the middle of that thing.
I'm doing it while you do it. Don't look up.
I got 0.28.
I got an error.
I got 0.28.
0.28. If you got an error, is it a sign error? You got an error, you probably just didn't go. You got to make sure you're to the left of the x-intercept and then to the right of the x-intercept. If you didn't change signs as you went, it wouldn't do it. That's this other 0. On yours, if you just, once you do root, it takes you to 1. If you hit right, the right arrow, it should take you to the next one.
Mine
There are
is
two different sets of coordinates.
Because it's crossing two different places. It has two answers. Think about this. Think about it like this. If you had x squared equals 4, right, and you took the square root, how many answers do you have? Come on, guys, you can get this. What's the square root of 4? 4. Woo! It's plus or minus 2, right? How do you get 4 when you square a number? Well, you could square 2 and get 4, or you could square negative 2 and get 4. So you get 2 answers there. That's why I'm getting 2 answers with a quadratic. I got a plus and a minus when I do a square root.
So you're
Okay?
gonna have 2 x's and 2 y's?
You're going to have 2 x's. The y's are going to be 0 each time. Okay? I don't want you to. It's not that I don't want you to. But chapter 3, we're really going to get into the whys of it, and we're going to get into solving equations right now. I want you to understand that any equation you're given, it doesn't matter if it's something you have never seen before and it is the wonkiest equation in the world. If you put a 0 in for y and you graph it, you can solve it for x by finding where it crosses that x-axis.
So really, we're not doing y because we're solving for x.
Right. Right.
How does it only take 32?
Shh. As you look at this one,
That's easier.
the y-intercept's easy on this one, right?
Yeah.
It's what?
Negative 3.
Negative 3.
Oh yeah.
So if I asked you to solve by graphing, here's what I want you to do. This is what I want your homework to look like. I want you to sketch a graph.
Mm-hmm.
Negative 3.
It went off.
It's gone forever.
It's getting on my nerves, I'm not gonna lie. I don't know. Because it's Bluetoothed in. And so if there's any little change in the signal or anything like that, it just. All right. So this is what I'd want, and then I want you to find this value, okay? So use your calculator. If it says solve by graphing, this is what we're doing. If it says solve algebraically, I would just add 3 multiplied by 4 over negative 3.
How do I know something? Is left above or on?
Graph it and look at it. Graph it on your calculator. Y equals negative 3 over 4. Yeah.
Is left down above or under?
Hold on, let me show you.
4.
All right, look, I told you this was going to be the place where everybody struggled the most. I don't know why students don't understand left bound, right bound, and I don't know how else to explain it. I've tried for years. Whenever you calculate your 0, okay, so let's go through it again. Second trace, number 2. It says left bound. I need to keep clicking left until I have cleared the 0. The 0 meaning the place where it crosses the x-axis. I'm not sure that I'm cleared. I need to be positive that I'm cleared. I'm going to keep hitting left. I'm sure that my little spider is now on the left side of it. I have clicked left enough that it has crossed, so I'm going to hit enter. Now right bound, I'm going to do the same thing, but I'm going to keep hitting right until I'm sure that I have cleared that. At the end, what I want is I want my two arrows giving me an interval at which my graph crosses the x-axis between those two,
And it's
someplace. So hit enter one more time, and I get -4.
This one's so much easier. You just click
This might be the easiest.
analyze, and it like gives you 2 dots, and you click the dot, and click the zero.
That's what I got.
Which class?